So we'll do the second one there, which is area and volume. Here we're looking at the area of triangles, we're looking at the area of sectors, and we're looking at the area of circles. So there's loads going on here that we're able to work with. We've looked at all of these individually. So we've looked at the area of triangles, we've looked at the area of sectors, and we've looked at the area of circles. So we should be able to answer this question. But it's just using all the different pieces of information that you have developed and putting them all together. So that's the key thing here, right? So the question asks, the diagram shows quadrant AOB of a circle of radius 14. So it has a radius of 14, it shows the quadrant. So that just means it shows a quarter of a circle. Taking pi equals 22/7, find the area of the shaded portion of the figure. So it says find the shaded area of this figure. So there's loads of different ways we could do this. The way I'm going to do this is I'm going to deal with the sector. Okay, so I'm going to turn that into a sector, which looks like this. A little bit squiggly, but it's not too bad. This is 90 degrees. This is 14. This is obviously 14. And we've got a line going straight down there. And this is obviously the shaded region here. So they want us to get the area of the shaded region. Okay, so first thing we need to do is we need to get the area of the sector. So the area of sector is equal to theta over 360, all multiplied by pi r squared. Now, you need to be familiar with how these formulas operate. So pi r squared is the area of a circle. Theta over 360 just means what portion of the circle we're dealing with. So in this case, I'll be dealing with 90 out of 360. So I'll just do that up here. So theta is equal to 90. Therefore, theta over 360 will simplify down to 1/4. And we can see that this is a very straightforward one, because 90 divided by 90 gives you 1, 360 divided by 90 gives you 4, and you can tell by looking at this is a quarter of a circle. So what this formula is doing, this part here, it's important that you realize that, this part here is getting the area of a full circle, and by multiplying it by this part here, I'm getting the portion. So I'm just getting this portion here because I'm multiplying it by a quarter, so I'm only getting a quarter of a full circle. Okay, so I'm going to fill in that information down here. So theta over 360 ends up being 90 over 360, which simplifies down to 1/4. So I can put in 1/4. And inside here for pi r squared, I can put 22/7 for pi. And for r squared, the radius squared is going to be 14 to be squared. So I can write that like that. If I was to work out what that is, I'd have to type it into a calculator. So 1/4 multiplied by 22/7 multiplied by 14 to be squared gives me 154. And that's centimeters squared, because centimeters times centimeters gives you centimeters squared. You can see here, there's no centimeters here, there's no centimeters here, but here I'm multiplying centimeters by centimeters, so I get centimeters squared. The next thing that I need to do is I need to work out, so I know the area of the full sector at this stage. So the full sector is 154. So that means everything inside here is 154. I now need to work out the area of the triangle. And if I can work out the area of the triangle, I can subtract that to find out the area of the shade region. So the area of a triangle is half the base times the perpendicular height. In this case, it's 1/2 of the base, which is 14, times the perpendicular height, which is 14, and half of 14 times 14 is 98. And again, that's centimeters squared. So the last part is the area of the shaded region, which is going to be equal to 154 subtract 98. So 154 subtract 98 will leave you with 56 centimeters squared. And that is your final answer for the shaded region. Okay.